Hi children, welcome to this class. Till now we discussed about the neuron at resting phase and depolarization phase. Let's start with the repolarization. Whenever the wave of depolarization reaches to the adjacent area, then it becomes again polarized. When depolarization passes to the next area, adjacent area, the part where the depolarization takes place again gets its potential charge. It is called as repolarization. What is happening in the name itself is there. Polarization come back. That is called as repolarization. Okay, what will happen? We focus on the ion channels. What is there? What happened there? The voltage gated channel of potassium is open, sodium is open. The activation gate of sodium open, inactivation gate of sodium is closed. The activation gate of sodium open and inactivation gate of sodium closed. At the same time, activation gate of potassium is open. Then what will happen? The influx of sodium ion is checked with this inactivation gate of sodium. So what will happen? The positive charge inside is reduced gradually. Then it again possesses the resting membrane potential, that is negative charge inside, positive charge outside. That is called as repolarization. Wherever the potassium ions also open, channel is open so that the potassium ions are positive, the remaining positive ions also goes out. Efflux of potassium ions started. Then what will happen? The positive nature still decreased. It gains the negative charge. So it is called as repolarization, or if you observe the graphical representation, the minus 70 millivolts is at resting position. Then it received the stimulus and gains the positive charge. Whenever it receives stimulus, the charge is reduced. Then it reaches the influx of sodium and gain the spike potential at minus 45 millivolts. It won't remain there only. It comes back again. That is called as repolarization. Whenever repolarization takes place, the charge will fall down. That's why it is called as falling phase. So the potential value may typically goes more than the negative charge at resting phase. So it may leads up to minus 90 millivolts also. So that is called as hyperpolarization. Polarization may be very low level, that is called hyperpolarization. It is also called as undershoot. The value may be minus 90 volts. Okay, if you observe this response of voltage gated channels of sodium and potassium, this table is also given in your textbook. This is most important. Sodium activation gate, sodium inactivation and potassium activated gated channels. At resting phase, these two are closed and inactivation only open here. Inactivation only open here. At depolarization, what will happen? Sodium activation, sodium inactivation are open and potassium are closed. Here sodium activation, inactivation open, potassium are closed. Here repolarization, sodium activation and potassium activation two are opened, sodium inactivation are closed. At the hyperpolarization, sodium activation, inactivation two are closed, potassium voltage gated channels are open. Because these channels are very lazy channels, they will close slowly. That's why the response, speed of response is also given. Sodium activation, activation gates are work fast. Sodium inactivation and potassium voltage gated channels work slowly. Okay.